One of the most important topics in finance is the time value of money. A dollar today is worth more than a dollar tomorrow because if we have that dollar today, we can invest it and earn interest on it. We're going to spend a lot of energy trying to find the present value, the value today of future sums, and the future value of sums that we invest today. And one of the great tools to help us do that is to use timelines to visualize exactly what's happening. All right, let's do a quick one. What will $100 grow to? If we invest $100 today, what will it grow to 3 years from now, assuming a 5% interest rate? And the form of these timelines isn't crucial. I usually like to put my dollars on top of the line. Our book likes to put them down here. But what's important is the linear nature, of course, and helping us visualize. This problem's pretty simple, but when we get to valuing a corporation based on the present value of future free cash flows, or valuing a corporation based on future dividend streams, it's going to get kind of complicated. And timelines are going to be very helpful. Let's do this one real fast. We'll hit second, clear time value menu. And you can put these in any order in the calculator in the third row here, but let's try to remember to go left to right. What's the N? That's the number of periods. There's 3N. What's the interest per period? It's 5. And in the calculator, we don't have to put in 0.05. We put in 5. What's the present value? We're putting out $100. We're putting out $100 today. Are there any payments being made in the meantime? No. So 0 is the payment. And we want to know what the future is, so we hit compute FV, and so $100 will grow to $115.76 over the course of 3 years, assuming a 5% interest rate. All right, let's do the reverse. Let's say we're going to receive $115.76 3 years from now in a 5% market. How much is that $115.76 worth today? We'll hit second, clear the time value menu. We'll can put these things in any order in the third row, but let's try to put them in left to right. 3 is the number of periods. 5 is interest rate per period. PV is what we're trying to solve for. There is no payment in the meantime. And the future value is 115.76. Let's change the sign on it, just so that when the calculator spits out an answer, it'll spit out a positive number for us. We'll hit compute PV, and sure enough, there's that $100. Okay, the way these time value of money problems work in class and in the real world, you may have noticed there's 5 variables down here in the third row. Depending on the nature of the problem, sometimes they give you 3 and you have to solve for the 4th. Sometimes they give you 4 and you have to solve for the 5th. And you can solve for any of them. So let's solve for I. We have $100 today, and 10 years from now, that's going to grow to $150. So how much does that earn us? What's the effective interest rate on that transaction? We'll hit second, clear time value menu. And again, we'll try to work from left to right. So what's the N? 10 is the N. I is what we're trying to solve for. What's the PV? Let's say we put $100 out of our pocket today, so we'll make that a negative number. There's no payments that we're making in the meantime, but in the future we have $150. And so we'll solve, compute I, and it gives us 4.14%. All right, let's solve for N, the number of periods. We're going to invest $500,000 today. It's going to earn 4.5% for us every year. How long will it take to grow to $1 million? Well, hit second, clear the time value menu. What's the N? Well, that's what we're trying to solve for this time. The I is 4.5 interest per year, per period. $500,000 is how much we're putting out of pocket today. So we'll put that in as the PV. There are no payments to be made in the meantime, and we're going to receive $1 million at the end. So let's compute N, and we get 15.75. Let's talk about annuities. Annuities is the same amount of money every period being received or being paid out. And an annuity is a situation where the money is paid at the end of the first period, at the end of the second period, at the end of the third period. An annuity due, which we'll talk about in a second, is where the payment is made at the beginning of the first period, at the beginning of the second period, at the beginning of the third period. So we can find future values and present values of annuities. Let's say we're going to receive $100 every year at the end of the year for 3 years, and the effective interest rate is 5%. What will that grow to? So we'll hit second, clear the time value menu. 3 is the N, 5 is the I. There's no money coming out or going in at time 0. The payment is $100. Let's make it a negative so that when we solve for the future value, we'll get a positive number. And we'll hit compute future value, and that will grow to $315.25. Right. An annuity due is like an annuity, except the payment is made on the first day of every period. And if you think about it, that means we earn an extra period of interest on all these payments. The easiest way to change the answer for the future value of an annuity to an annuity due is to take that $315.25, multiply it times 1 plus the interest rate. So we'll take 315.25, multiply it times 1.05, and that'll give us 331.01. There is a way to do it on the calculator, but there's an inherent danger. Danger, danger, danger. So what we'll do is we'll go to second, begin. See that BGN over there above the payment? And we're going to go second, set, and now it's set to begin. We'll hit second, quit, and now up in the upper right-hand corner are the letters BGN. And the danger is that you will forget, I have, to reset that thing back to end when you're done, because most of the time annuities are annuities, not annuities due. But let's plug the numbers in anyway. So what's the N? 3 is the N. What's the I? 5 is the I. There's no PV, but the payment is 100. And what does it grow to? Compute future value. And there's that 331.01, which you already calculated. All right, now here's what we got to do right now. Hit second, begin, second, set, second, quit. And now it's set back to end where it belongs. All right, finding the future value of annuities is fun, but in my entire career, I've never once had to find that. We're almost always in finance looking at the present value. What are future cash flows worth today? So let's have that annuity of $100 per year for 3 years in a 5% market, and let's find the present value of that. We'll hit second, clear time value, and the N is 3, the I is 5%, PV is what we're trying to solve for, 100 is the payment. Let's make it a negative sign so that when we solve for the PV, we'll get a positive sign. We'll hit compute PV, and that's $272.32. By the way, what does that mean? What that means, if somebody comes to you and says, would you rather have $100 every year for 3 years, or would you rather have $272.32 today? The answer is those are the same amounts of money in a 5% market. Those are exactly the same. Okay, last one. The present value of an annuity due in a 5% market where the payment is $100 per year over 3 years. Again, I highly recommend that you not use the calculator. If you find the present value of the annuity, take that $272.32 and multiply it times 1 plus the interest rate, because what's happening here is we're getting an extra period of interest on all that stuff. And you take that 272.32, multiply it times 1.05, and you get 285.94. But let's check ourselves. Let's hit second, clear. That clears the time value menu. We'll go to second, begin, second, set. That sets it on begin, second, quit, and now we'll fill in the numbers. What's the N? 3 is the N. What's the I? 5 is the I. PV is what we're trying to solve for. $100, let's make that a negative number so it comes back as a positive. That's our payment. There's no big payment due at the end. There's no future value. So then we'll hit compute PV, And sure enough, there's the 285.94, which we got by taking that 272.32. And then what we're going to do is immediately hit second begin, second set, second quit. And now the calculator is set back to the more conventional end. I hope that helps.